Okay, so it's asking for the seventh term in this sequence. So we can tell that this is geometric because when you multiply by 4, you get the next term. So the common ratio is 4. A sub 1 is 3. So we're going to use the explicit form. So f of n equals the first number times the ratio to the n minus 1. And we want f of 7. So it's 3 to the 4, 3 times 4 to the 7 minus 1, which is 3 times 4 to the 6th. So the answer is 12,288. Alright, so the explicit rule for arithmetic sequence is the first number plus the difference. The common difference is 2. Now because n is starting with 0, it's not n minus 1, it's just n. And then we just say n greater than or equal to 0. And so this would be the formula. Okay, so the difference is 4 on this one, on number 3, because from here to here is 4, from here to here you add 4, and so forth. And here to here. So f of n equals the first number plus the difference, and again, because we're starting with n equals 0, it's just n for all n greater than or equal to 0. So this is a geometric series. The common ratio to get from one to the next, 4 times 4 is 16, 16 times 4 is 64, etc. So the common ratio is 4. The first number is also 4, and then n we don't know, okay, because there's a, the dot, 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 the ellipsis, so that's not, we don't know. We have to figure it out. So f of n, we're going to do the explicit formula. F of n is the first number times the ratio to the n minus 1. Okay, so we can rewrite this because notice here the 4, they're the same number, and that's a 1. And so I can combine this and write it as 4 at the exponents, and you get 4 to the n. And so then replace this with 16,384, which is the last number. 16,384 equals 4 to the n, and we're going to use the guess and check method. So I tried a couple of numbers, actually 3. I tried 5, the number was too small. 4 to the 5th power was like 1,000 something. Then I tried 8, and it was too big, it was like 64,000 something. And so then I went down and I tried 7, and that one worked. So that means that n is 7. So I'm going to go to the sum formula. S sub 7 is the first number times 1 minus the ratio to the 7th power over 1 minus the ratio. And so that's going to give you, move down a little bit, that's going to give you 4 times 1 minus 16,384 over negative 3. And then, so you subtract 1 from 1 minus this number, so that gives you here, this number, negative 16,383, divided by negative 3, so you get this. And then 5,461 times 4 gives you the final answer. Okay? And that's it for number 4. So for this one, the ratio 3 times negative 2 gives you negative 6, and negative 6 times negative 2 gives you 12, so the ratio is negative 2. The a sub 1 is 3, and we don't know the n right now. So we're going to use the explicit formula. F of n equals the first number, first number times the ratio to the n minus 1. Now this one we cannot combine the bases like we did on the other problem in the previous one. So we're going to leave it like this and replace f of n with negative 15,036 equals 3 times negative 2 to the n minus 1. Divide by 3. And so when you divide here, you get negative 512. And so now we have to guess what negative 2 to what power is going to give us negative 512. Excuse me. So I tried several numbers, and what works, negative 2 to the ninth power gives you negative 512. Okay? So that means that n minus 1 equals 9. So that means that n is 10. Okay, that's the number of terms that we're adding together. So s sub 10 equals the first number times 1 minus the ratio to the 10th all over 1 minus negative 2. Okay? And you get 3 times 1 minus, and then 1 minus the negative 2 in the denominator is 3. So you get negative 2 to the 10th power is positive 1024, so it's 1 minus 1024 divided by 3. Now the 3 over 3 I can cancel, and so here's my answer right here. Okay, so for number 6, the common ratio, what do you multiply to get from here to here to here, is positive 3. The a sub 1 is negative 2, and there are 1, 2, 3, 4, 5 terms that we're adding together. The formula, s sub 5 is negative 2. This is the formula for the sum, remember, not the explicit form or the explicit rule. So negative 2, that's my first number, times 1 minus the ratio to the 5th over 1 minus the ratio. So in the next step, I took a calculator and did 3 to the 5th, and I got 243, and then 1 minus 3 is negative 2. Then I subtracted here, I got negative 242, and so now the negative 2 and the negative 2 are canceled, and so the answer is negative 242. Okay, so for number 7, the common ratio is negative 4. That's what you multiply this number to get that number, and so on. The first number, the first term is negative 2, right here. We don't know how many terms there are in this series because there's some numbers missing in here. Okay, so we have to figure this out first before we could find the sum. So here's the explicit formula or explicit rule. F of n equals the first number times the ratio to the n minus 1. So what I did is I replaced this with 2048, the last number. And so now I'm going to solve for n. Okay, so divide by negative 2 on both sides. So now I have negative 1024 equals negative 4 to the n minus 1. So now I'm going to try different numbers, powers of negative 4 to get negative 1024. Now I'm going to use odd numbers because if my outcome has to be negative, then the exponent for negative 4 has to be an odd number. So I'll try some odd numbers. Okay, so I tried some numbers, and it turns out that negative 4 to the 5th is equal to negative 1024. So that means that n minus 1 has to equal 5. So that means that n equals 6. So now I'm going to do sum of 6 equals the first number times 1 minus negative 4 to the 6th over 1 minus negative 4. So that's going to give me negative 2, 1 minus, and I'll do that on the calculator right now. The denominator, 1 minus the negative 4, is actually 5. So negative 4 to the 6th power is 4096. Then I subtracted that from 1, and I got negative 4095. Now you're going to divide it by 5, and that gives you negative 819. And so times negative 2 gives you positive 1638. And that's sum for that series. So this is another geometric series. So the ratio is negative 2 because that's what you get. That's what you multiply by to get the next term. And then a sub 1 is 10, and we're trying to find n. So I wrote the explicit rule, and then I replaced f of n, this f of n, with the final number, with the last term. So now I'm going to divide by 10. So I get 256 equals negative 2 to the n minus 1. So now I'm going to just try different numbers for exponents for negative 2 to give me 256. Now since I want a positive 256 and I have a base of negative 2, I'm going to try even powers of negative 2, okay, to see what gives me 256. So negative 2 to the 8th power is 256. So that means that 8 equals n minus 1, so that means that n is 9. Okay, so now I could do s of 9 equals the first number times 1 minus the ratio to the ninth, because that's what my n is, over 1 minus the ratio. And so that's 10. 1 minus the denominator is 3. And so 2 to the ninth would be 512. So then that gives you 10 times... So negative 2 to the ninth power is actually negative 512, and then there's a negative right here. So that's going to make it a positive. So 512 plus 1, 513 divided by 3. And the result of that divided by 3 is 1,710. So you take 6 to the 6th power here, and you get this. And then 1 minus 6 is negative 5. And then 1 minus this 46,000 number is negative 46,655 divided by negative 5 gives you positive 9,331 times 2 gives you the final answer of 18,662. The first series or sequence is arithmetic. The difference, common difference is 5. The second one is geometric. So this one is yes, and the ratio is 3. The third one is arithmetic. The difference is 2. And the last one, D, is geometric. The ratio is 2. So this sequence is arithmetic because it has a common difference of 4 from here, here to here. So right off the bat we could say C is false because it says that it's geometric. So that is false. So the difference is 4, so we say f of n equals the first number plus 4 times n minus 1 for all n greater than or equal to 1. And so we distribute the 4, so you get 1 plus 4n minus 4. So when you combine these two, you get 4n minus 3 equals f of n. Okay, so that one would match A. So this is true, therefore this one is false. So the first term, replace the n with a 1, and that gives you 2 plus 1 is 3. And after that, you can just add 2 because that's the common difference right there. So 5, 7, 9, 11. 2, 4, 5. So that would be the answer to the first part. Then it asks you later on whether this function, it says what kind of function would it be if you were to graph it on a coordinate plane. So this one would be a linear function. Okay, if you graphed it and drew the dots, they would lie in a straight line. An examples vary. I mean, you could pick a let's see, this could be like if an example, if you have a cake with diameter 3 inches, and then the top tier would be 3 inches, the next tier would be 5 inches, and then 7 inches, and 9 inches, like a wedding cake type of thing, where the top one would have that diameter or a radius, and then the next one down that one, and like that, and so forth and so forth. That's just one example.